Oh, wow. When he gets to eat the treats, it's no bother. But when he has to make them, it's all of a sudden, woe is me. I like you better with the dress. Yes, question. Oh, how did Amber get one and you not? Okay. Can you hand this to Emerald, please? Okay. So we are almost ready to start chapter 4, but we have really kind of just this one small lesson left. And so today's a good spot to just cover half of it. And then on Wednesday, we cover the other half. And on Thursday, we start chapter 4. And actually, we could do whatever I want. Uh, so here we go. Linear approximation, differentials we'll learn about on Thursday or on Wednesday, but linear approximation today. Yes. Probably not. We probably won't be able to quite reach a test. So here we go. Linear approximation. Suppose we have a curve, and we'll call it f of x. And I'm going to draw a line tangent to that curve with my handy-dandy line paper. And we're going to call this, so this is y equals f of x. We'll call this y equals L of x, meaning the linear approximation. Okay? So, is that line the same as the curve? No. However, if I zoom in to a very close area, are they approximately the same? Every single curve may be approximated by a line so long as you zoom in close enough. Okay? We've kind of talked about this type of theory before, haven't we? And we're going to call this A, and we'll call this right here f of A. Then the linear approximation of the curve is simply the line tangent to the curve, which we've done before. We're just going to use new notation because this notation will be used in the future. When you say, can we do it the old way? Go ahead. Just realize that it's probably more helpful to use the notation that we're going to use here, okay? In order to write equation for a line, you need two things. You need slope, and you need a point on your line. Anybody identify what this point on the line is right here? A, f of A. So, m, okay? M would be the slope. How do I find the slope at that point? Slope of L of x, which would be what? The derivative of f evaluated at point A, f prime of A. Everybody okay with that? So therefore, if we want to write an equation for the linear approximation, we would say y minus the y1 values f of A equals m is f prime of A times x minus A. Yes. At that one point, they are the same. Or y is equal to f prime of A times x minus A plus f of A. Everybody okay with that? So, why would the linearization of a function be useful? It allows us to approximate values within a small interval. Got it? Find the linearization of the following functions. So all we're going to do is find the linearization. Linearization, if you see this term on the AP Calculus test or in future years or any time, you just want to think about the equation for the line tangent at the given point. So first what I must do is I must decide what the point on the line is and the slope. What is the point on the line going to be? 1, not 2, but 3. Plug it back in, very good. Because 1 squared is 1 times 4 is 4 minus 1 is 3. Your slope, you would first find the derivative. Y prime is equal to 8x. So in order to find the slope, I plug in 1 and I get 8. So again, y is equal to f prime of a times x minus a plus f of a. What is f prime of a? 8 times x minus, what's my a value? 1 plus, what's f of a? 3. So y is equal to 8x minus 8 plus 3. Y is equal to 8x minus 5. Any confusion? Now, would this line approximate the parabola everywhere? No. If you would think of this parabola, it shifted down 1 unit, it looks something like that. Okay, and this graph looks something like that. You can see that in this very small region right here, it probably does a very good job of approximating it. But for like -8, it would not approximate it very well at all. So this is the linear approximation near the point x equals 1. Near x equals 1. It only works if you suggest what point it is near. Yeah. All right, so the next one, try some trig. Point on the line, pi over 2, what? That'll be the sine of pi, which is pi is over here, correct? And so what coordinate on the unit circle does that pass through? -1, 0, correct? So that's x, that's y, r is always 1, and sine is equal to, sine of theta is equal to y over r. So if you take y, which is 0, divided by r, you get 0. So anytime you're asked to evaluate sine, cosine, or tangent of given values, you need to think of the unit circle, the points that you have. But I know your college trig teacher taught you all that stuff and gave you an excellent graphic organizer that you can use to memorize those values. Slope. I need to find the derivative. What is the derivative of -2 cosine of 2x? I have to use the chain rule. Derivative of the inside is 2 times derivative of the outside is negative cosine. Inside left alone, 2x. Plug in pi over 2. What is 2 times pi over 2? Pi, cosine of pi. -1. You don't know what we're doing? We found the derivative of sine of 2x. Now we're going to plug in pi over 2 to find the slope. 2 times pi over 2 is pi. Cosine of pi is -1 times -2 is 2. y equals f prime of a times x minus a plus f of a. Y equals f prime of a, 2. X minus, what is a? Pi over 2. What is f of a? 0. Luke, I like the haircut. And the suit. And the witty side comments you make. Y equals 2x minus pi. That is the linear approximation of the curve at the x value pi over 2. F of a is 0. I got left off. Okay, let us now do one last problem for today. That's it. Find the linearization of f of x equals 4 minus x. Use it to approximate the values of square root of 3.99 and square root of 4.1. Back in the day, they did not have the calculators to be able to produce values of square root of 3.99, square root of 4.1. They would use calculus to approximate these values. This is really actually a great idea. And it leads us into an idea called Newton's method later on, which is absolutely genius. And you guys will love it. So let's find the linear approximation, okay? What's that? Oh. I'm going to do the linear approximation at x equals 0. Does anybody know why? Because if I plug in 0, I will get the root of 4. Furthermore, if I plug in 0, that's very close to these two values, correct? So if I want to estimate these values, it would be nice if I could estimate the square root of 4. That's what this would be at x equals 0, correct? Yes. So, yes. Exactly. Yes. So M and point on the line. What is the point on the line? 0, 2. So that's my y-intercept, isn't it? Isn't that nice? How do I find the slope? What is the derivative of the square root of 4 minus x? I have u to the 1/2. What's the inside? What's the derivative of 4 minus x? I have 1 over 2 roots of u. Are we okay with that? I plug in 0 to find the slope. What do you get? Negative 1/4. So therefore, okay, in this situation, I have y is equal to negative 1/4 x, and I know the y-intercept. What is it? If you wanted to estimate the square root of 3.99, what x value would you choose? 0.01. Does that make sense? Or 1/100. If you wanted to estimate 4.1, what x value would you choose? Negative 0.1 or negative 1/10. Are we okay with that? I'm going to put it as a fraction because it's going to make it easier in the long run for me. Okay? You do what you want. So, the linear approximation is y equals negative 1/4 x plus 2, given whatever x value we have. So let's just do this. Y is equal to negative 1 over 4 times x. What's x? 1 over 100 plus 2. What's negative 1/4 times 100? Or 1/100th? Negative 1 over 400 plus 2. I'll raise common denominators. This would be 800 over 400, right? So 799 over 400. Take out your calculator. Watch. Take the square root of 399. I'm sorry, 3.99. And we get 1.997498, so on and so forth. Now take 799 and divide it by 400, and you come up with, whoa, is that a good approximation? It's an excellent approximation. So you can see why, if you did not have the ability to punch in your calculator what the square root of 3.99 was, how do you come up with a reasonable value? A lot of times calculus offers you that opportunity. And it has great application in word problems for time to come as well. Okay, let's do another one. Okay. Okay, there we go. Now we have x is negative 1/10. Y is equal to negative 1 over 4 times negative 1 over 10 plus 2. So y is 1 over 40 plus 2, or y is 81 over 40. So is 81 over 40 a reasonable estimate? So if you take the square root of 4.1 and you compare that to 81 divided by 40, you can see, look at how close of an approximation that is. Hold on real quick before you go. Last thing. The last question was, is it an overestimation or an underestimation? Just watch this real quick. You'll get it. Okay? It won't take but a second. What does the graph look like of y, or f of x equals 4 minus x? Looks like that, right? We drew a line at 0. Okay? This line, is it going to over approximate the x values or under? Over approximation. Okay. See you guys.